Amazing modern basement construction technology. The journey of basement construction begins with the foundation slab. Shuttering, also known as formwork, is the process of creating a mold or framework into which concrete will be poured. In the context of basement construction, the shuttering for the foundation slab involves setting up wooden or steel formwork to define the shape and dimensions of the slab. Careful measurements and leveling are crucial at this stage to ensure the foundation is precisely aligned with the builder's plans. Once the shuttering is in place, it's time for the concrete to take center stage. The foundation slab is typically made from reinforced concrete, which provides the necessary strength to support the weight of the building above. Concrete mixtures are prepared according to engineering specifications, and then it's poured into the formwork. Vibrators are used to eliminate air bubbles and ensure proper compaction, while finishing tools help achieve a smooth surface. To create the walls of the basement, external precast twin wall panels are employed. These panels are pre-manufactured off-site to exact specifications, ensuring uniform quality and minimizing on-site construction time. Once delivered, they are carefully installed around the perimeter of the foundation slab. The interlocking design of twin wall panels provides stability and insulation, enhancing the overall structural integrity and energy efficiency of the basement. Similar to the external walls, precast ground floor panels are used to form the base of the basement. These panels are designed to support the weight of the building above while providing a durable and waterproof foundation. They are placed on top of the foundation slab and secured in position, creating a solid base for the structure. To ensure the basement can withstand the load of the building and resist potential ground movements, the ground floor slab is reinforced with steel bars or mesh. This reinforcement adds tensile strength to the concrete, preventing cracking and improving overall structural stability. Careful placement and spacing of reinforcement materials are crucial for optimal performance. Basements are susceptible to water ingress, and to combat this, watertight light wells are installed. These light wells provide natural light and ventilation to the basement while also acting as a barrier against moisture infiltration. They are typically constructed with waterproof materials and carefully sealed to prevent any leaks. To further enhance the basement's waterproofing and protect against moisture penetration, a layer of lather bitumen tanking is applied. This waterproofing membrane forms a seamless barrier on the interior surface of the basement walls and floor, ensuring a watertight environment. To improve energy efficiency and thermal performance, external insulation is applied to the outer walls of the basement. This layer helps regulate temperature and reduce heat loss, making the basement more comfortable and cost-effective to maintain. With all these critical steps completed, the basement construction process is ready for the superstructure. The basement now provides a sturdy and secure foundation for the rest of the building to rise upon. Once the superstructure construction commences, the basement's role as a functional and valuable space within the building becomes evident, whether as storage, additional living space, or housing essential building systems. The construction method known as the industrialized building system. The industrialized building system is a modern construction method that addresses the key priorities of the construction industry, including speed, quality, and cost efficiency. This system involves the manufacturing of building components in a controlled environment away from the construction site, followed by their transportation to the site for assembly. IBS has gained popularity due to its ability to deliver quick construction, maintain high-quality standards, minimize wastage, reduce the need for on-site workers, and ultimately lower construction costs. Malaysia has recognized the potential of IBS as a means to supplement its economic growth in the construction sector. The government, through agencies like the Construction Industry Development Board, CIDB, is actively promoting the adoption of IBS by providing knowledge and training to construction professionals and rewarding construction projects that implement IBS with an IBS score. The IBS score is a significant component of this approach, emphasizing the use of prefabricated and standardized building components as well as repeatability. The maximum IBS score for a building project is 100 points, and it is divided into 3 parts. Structural system 50 points. This part assesses the use of IBS in the structural elements of the project. Key elements contributing to the score include precast concrete components and their adherence to established standards. Wall system 20 points. The wall system score focuses on the implementation of IBS in the construction of walls. This includes the use of precast concrete wall panels, their positioning within the structure, and the application of grout to secure them. Other simplified construction solutions 30 points. This part evaluates various other aspects of the construction project that utilize IBS principles. It encompasses components like slabs, doors, windows, stairs, and roof trusses. In the practical implementation of IBS, several key components and techniques are employed. Precast concrete. Precast concrete plays a crucial role in IBS. This involves the manufacturing of components like columns, beams, and wall panels off-site. These precast elements are then transported to the construction site and assembled, contributing to a faster construction process. Basement construction. Basement construction, often a crucial component of building projects, entails the creation of a below-ground space that serves various purposes such as storage, recreation, or utility areas. To maximize comfort and energy efficiency in these subterranean spaces, Earth-Safe Products has introduced a cutting-edge solution that integrates sustainable technologies. One key feature of this basement construction project is the incorporation of the ESP Holotherm Sensor Comfort Compact Underfloor Heating System. With an impressive 8 kilowatt heating capacity even at 7 degrees Celsius, this system ensures a cozy and warm environment in the basement year-round. Its efficiency lies in harnessing the power of renewable energy sources, making it environmentally friendly and cost-effective. This combination of technologies not only ensures a comfortable and energy-efficient basement, but also aligns with a growing global emphasis on sustainability. By reducing reliance on conventional heating methods and tapping into renewable energy sources, this basement construction project represents a step towards a more environmentally responsible and economically advantageous approach to home construction. The process begins with architectural and structural design. The design team creates detailed plans that include the size and thickness of panels, reinforcing steel layout, door and window openings, and any architectural finishes or textures desired for the exterior of the building. Once the design is finalized, the construction team begins fabricating the tilt-up panels. This typically involves creating wooden or steel forms on the ground into which concrete is poured. Reinforcement bars, rebar, are placed within the panels to provide structural integrity. Any architectural details, such as brick patterns or texture finishes, are applied to the inside surface of the forms. Concrete casting. Concrete is poured into the forms, and it may be a special mix designed for strength and durability. The concrete is vibrated to eliminate air voids and ensure a smooth surface finish. It's also common to embed lifting inserts or anchors into the panels during casting to facilitate the lifting process. After the concrete has been cast, it undergoes a curing process to strengthen and set. This can take several days depending on the concrete mix and weather conditions. Once the concrete is cured, the panels are often finished with any desired architectural details or surface treatments such as paint or textured. Coatings or architectural reveals. The most distinctive aspect of tilt-up construction is the lifting process. A crane equipped with special reading attachments is used to lift the panels into a vertical position. The lifting process requires careful coordination to ensure safety and accuracy. The lifted panels are carefully placed into their designated positions, usually on the building's foundation or slab. Precise alignment is critical to ensure that the panels fit together seamlessly. Once the panels are in place, they are connected to the building's structural system using methods such as welded steel plates, dowels, or epoxy anchors. These connections provide stability and structural integrity to the overall building. After the panels are securely in place, the construction of the roof, interior partitions, and other building components can proceed. The tilt-up walls provide the building's shell and structural framework. Advantages of tilt-up construction. Cost-effective. Tilt-up construction is often more cost-effective than traditional construction methods as it reduces labor and formwork expenses. The use of locally sourced materials and simplified construction processes also contribute to cost savings. Speed. Tilt-up construction is known for its speed. The panels can be cast simultaneously while site work, foundations, and utilities are prepared, leading to shorter overall construction schedules. Customization. Tilt-up buildings can be designed to meet various architectural styles and functional requirements. Customization in terms of panel shape, size, finish, and architectural detailing is readily achievable. Durability. Tilt-up panels are highly durable and resistant to fire, weather, and pests. They provide excellent thermal mass, which can contribute to energy efficiency and reduce operating costs. Environmental benefits. Tilt-up construction can be environmentally friendly. It minimizes construction waste, allows for recycling of materials, and supports energy-efficient building designs. Applications of tilt-up construction. Warehouses and distribution centers. Tilt-up construction is commonly used for industrial buildings due to its cost efficiency and speed of construction. Retail centers. Many shopping centers and retail stores have been built using the tilt-up method, offering flexibility for storefront design and layouts. Office buildings. Tilt-up construction can provide aesthetically pleasing exteriors for office complexes while maintaining cost-effectiveness. Educational facilities. Schools and universities have adopted tilt-up construction for classroom buildings, gymnasiums, and other structures. Healthcare facilities. Tilt-up construction is also suitable for hospitals and medical centers, offering the durability and flexibility needed for healthcare infrastructure. Recreational facilities. Sports arenas, community centers, and recreational facilities can benefit from the speed and cost savings of tilt-up construction. Limitations of tilt-up construction. Site constraints. Tilt-up construction requires ample space for panel casting and lifting. Sites with limited space may face logistical challenges. Crane availability. The use of a crane is essential for the lifting process, so crane availability and proper coordination are critical. Engineering and design. Careful engineering and design are necessary to ensure that the panels can withstand wind loads, seismic forces, and other structural requirements. Skilled labor. Skilled labor is required for panel casting, lifting, and placement. Adequate training and experience are essential to ensure safety and quality. Panel size and weight. Larger and heavier panels may require specialized equipment and planning for transportation and lifting. Weather dependence. Weather conditions can affect the casting and curing of concrete panels, potentially causing delays. So this is the end of our today's video. Do you like it? Kindly give your valuable response in our comment section below, and don't forget to subscribe to our YouTube channel for more interesting and informative videos.